friends, today we have this model, and in this model if you will see we have one linear slot. So for this type of model we can create a groove milling. So let's go to the manufacturing, and in this manufacturing first of all I am going to define the center for this MCS mill. So click here, and this part is this, and the blank is a bounding block. Now double click here, and now I want to set this on blank and click here, this the center. Okay, right. Now we need a tool for this type of undercut. For this kind of linear groove we need T cutter to remove this material. So this is the groove milling. In groove milling we can machine only linear groove. Any circular cylindrical taper groove, it will not work with this type of slot or groove. We can machine only linear groove with the help of T cutter, and we have several strategies. Like if you want to cut in multiple depth, so it is possible, and if you want to cut in multiple pass, so again that is also possible. And we have some more cutting option, so that we can create finishing or roughing operation for this groove. And for tool we can use solid carbide tool or indexable T cutter tool for this kind of operation. So this linear groove will only work with this T cutter type tool, right? Here you can see this is the T cutter and it is cutting the undercut area. So we can use this type of tool for undercut linear groove shape. So before selecting this, I need a T cutter tool. So click here, and the tool is this T cutter. Click here and click on this point, and we can see whether it is properly. Right now you can see when it will work, the tool will work, it will touch up to this phase. So the neck diameter ending, the neck diameter will not collide with the part. So the length, the dia are okay. Just flute length is a little bit thick, so make it 4. Now we can cut it with this tool, and a little bit height I'm going to increase and click OK. Now create the operation, and my operation is this groove milling. Select the tool, workpiece, and here I am just selecting the finish operation. But you can perform roughing or finishing both operation with the same method. See here it is asking for the groove geometry, so I am selecting this groove geometry and make sure the Z direction should be in this MCSZ, right? It should be in up direction, so that the tool will come from Z direction. Okay, and if you will see this properly here, if you want to keep some material on the ceiling and floor, so we can enter here. Now it will work as a rough, and for wall again you can enter any value, so it will keep some material on floor, wall, and ceiling. So we can define this thing from here, otherwise keep this 0 for finish. Okay, and here I'm just generating this, then we will discuss rest of the option and verify and see. Okay, now from this replay, it is cutting the middle pass. Now it will cut on the top. See, it is cutting the top one. Now the bottom. Now it is working for bottom pass, right? So with the help of this cut level we can arrange it Here you will find center to ceiling. It means the first pass will be at the center, then second pass will go to ceiling, and last on bottom. If you want to change, you can change it from here, but it is advisable to select any center method so that if you will, if anything will be wrong, so we will have some material on top or on bottom, so we can make it properly finished, or we can create another toolpath so that we can cut this shape properly. So click here, and number of passes are 3. I'm going to use 5. Okay, and see, now the 5 passes are there, and you see here the depth per cut we have used passes. So in 5 passes it is cutting it. Now I want to add some step over. So step over 3. So this depth is 5. So it will cut in 3 passes. Now click here and check this. Right now, if you will see, we have the geometry after this, but it is cutting the whole blank. If we have already performed some operation on this area, it means we don't have any material here, so that time we need some changes. So select the groove geometry, and if you want your blank geometry up to this only, so in process workpiece you can select none, so it will detect the geometry only, it will not extend this up to the blank geometry, right? But in our case it is not okay, we need 3D geometry. So click here and select the use 3D. So 3D model it will check and it will generate the toolpath for this one. Okay, hope you understand this. If you have any query, you can comment me. Thank you for watching. Hello friends, in this lecture we will see face milling manual, and for that I have this part, and here we have 4 pockets. So for face milling manual I am going to remove these 4 pockets. Okay, now I need the blank. So with the help of geometry I am going to create blank geometry. So select extrude and extrude this, right, and select until selected, right, and okay. Right now we have part as well as blank. So now switch to manufacturing, and here manufacturing we have some options. So remove all this, and we will make this with new one. Now come to this workpiece and define the workpiece. The workpiece is the same, but here in blank, by it was previously it was used bounding block, but I'm telling you, if you have any geometry, you have created any geometry, you can also use that geometry as a blank. So it is also a convenient option if you have any customized work blank, so we can also use, because in geometry we can create any type of model. So it is required that you know about the NXCAD, about the modeling, so you can create the part and blank both. Right now we don't need this blank, so hide this, and here if you will see we have one tool. So I'm going to use this tool, but here I'm adding one folder. So yeah, medium compression folder I'm going to use. Right now come to this, and one more tool we have, but we will use this tool. Now click here, and the option is this face milling manual. So face milling manual is just similar to the floor and wall, except on each level we can define separate tool path, cut pattern for tool path. Right? I will show you. see here in manual, if you are creating, if you are going to cut this in 4 level or 5 level, so all level you can define separate cutting pattern, right? So same thing we will do with this. Okay, select the tool, workpiece, face milling manual, and okay, and here come and select the cutting face. And for wall I'm using automatic wall, automatically it will detect. And the cut pattern is mixed. Mixed means the height of this is, come to this analysis and click here for measure and measure this. It is 11.859, right? And depth per cut I'm using 3. So in 4 level it will remove. In 3 level 3, it 4. In 4 it will remove. Let's see. The first 1, 2, 3, 4. First I'm using zigzag. For second I'm using this periphery. For third I'm using follow part. And for last one I'm using profile, right? For each cut it will use separate tool path, separate cut pattern. Now generate. Okay, it is already generated, so no need to click again, just see the preview and see. First zigzag, now periphery. This option is not suitable for this component. I'm just telling you how to use this. Now it is profiling. I'm just showing you all the options how they will work, right? And we will also cover some project. In that project we will completely follow the manufacturing rule and all the tools and all the parameters, then we will create that project, right? This is just for the training purpose, that's why I'm covering all the sub option, all the tool paths. Okay, and okay. So this is a major difference. Otherwise, it is just similar to the floor and wall. Hope you understand. Thank you for watching. Have a nice day. In this lecture, we will see planar text. And for planar text, I have this cavity. And on this cavity, I want to text. I want to engrave something, some part number. So when you open a core or cavity, it will open in general template. Means you can switch in any module like manufacturing or design, wherever you want you can open it. So I'm opening this step file in modeling. Now double click here, and this time I want to align. Okay, and I want to place my Z in proper direction. So now it is approximately on center, or drag it and make Z in up direction. Okay, right? Now I want to place any text, so I need a position. For position I'm using sketch. Select this face, okay, and specify a point where you want to place your text, right? Finish. And this is the part, and this time I want to create blank geometry also. So use this extrude, and from here use this face edges and select the face. All edges will come, but I don't want all the edges because some holes are there, and it is also selecting all the holes. So reset and click single. I am going to use single. So single edge, single edge, single, and single. When it is closed, it will automatically convert into solid, and until selected face is this one, right? Keep none, right? And preview, not visible properly. What it is doing, remove this, again select, and single curve first, second, third, and the fourth one. Keep none, reverse direction, and make this until selected, and see this. I don't know why it is not properly visible. So I'm changing this until extended, and this is the face. Okay. Now this is a blank, and select this blank and make it transparent. So right click here, assign color. Here specify the color. Click here, anyone color you want, just select OK and OK. Right. Now move to manufacturing and planner. OK. Here double click here and place this on proper direction. Okay, and the 10 is the retract value, so I'm going to increase because we have some boss. Okay, just keep this, no problem, we will see. Okay, now we need the tool, and the operation is this planar text. Planar text will work over the flat surface or a planar surface in a fixed direction, right? See, planar text operation is engraving tool, engraving operation for any text which will done on a planar surface. We, we use part numbering or mold cavity ID number to engrave on the part or core cavity, right? So text should be parallel to the floor plan. So this is the floor plane, so it should be parallel, and it will work for three axes. And for engraving, we can use different type of tool. Mostly we use this type of tool for engraving any number, part number on the surface. This is also engraving. It is also engraving tool. All are the engraving tool. Mostly we use this kind of tool, right? But this engraving tool is not available here, so we will uh, create this type of tool. So before selecting this, click here and add a tool. So this time I am using this ball mill, and the taper angle is 10 and the dia is 0.5, right? And flute length is 10, and okay. So this is the tool, and we need a drafting text. For drafting text, you can click here and search note, or you can directly select from the menu bar and it will give you the result. So I'm using this note, So for directly, you can come to this insert, and here is a node. Select this node and the anchor point is this one, and xy, so this will work for xy direction. So the point is not properly, so select vertical, and now it is vertical. And one more thing, the size of the text is a little bit small, so go to setting, and here the text and the size I am using 6, and see, and here select the font. So I have selected txt font. Okay, and enter the text and select this point, right, and click here. If you will not place this note on a specific point, it will by default it will come on xy plane, right? So this is the text, and click here, path navigator, hide this blank. Okay, now come to operation and select the text, planar text operation, and the tool is this engraving tool. Okay, and here select the drafting text. If your text is properly, you can select it, otherwise it will not select, right? Okay, and the text depth is 0.25, and depth of cut if it is required, if you want to assign, and the specified floor is this space where this text is placed. Now generate, and you can see, click here and verify. Blank verification is required, so no problem, everything is done. Just click OK and OK. And I forget one thing, geometry we have not defined, so click here and come to this workpiece, and here the part is this one is my part, and for blank this is the blank. Okay, and OK. For now I'm hiding this and this both, and this text also, click here and hide this text also, so that we will see result properly. And if you will verify this toolpath, this will give you the result in 3D dynamic, and only IPW will display. Okay, if you want to cut this in multiple depth, you can also define the depth of cut, and if you want to increase the depth of this text, you can also define. Show. Okay, click here, double click here, and here this is the depth. If you want to increase 0.5 and generate, and here depth per cut is 0.25. In two passes this will cut. If you will directly verify this, it is not properly visible because of part and blank geometry. Second pass. Okay, okay, and hide and hide. Click and verify. Right, so hope you understand this properly. Thank you for watching. Hello friends, in this lecture we will see how to create toolpath for 2.5 axis curve. So this is the 2D curve which I have created with the help of image. So with the help of image, I have traced this image and I have created this 2D curve, or you can import any AutoCAD file. You can import AutoCAD DXF or DWG 2D file, and you can also create the CNC program with the same method. So first import the curve or create a 2D curve. Now if you want to see the 3D verification, we need a surface or a solid. For surface, I am going to click this surface, and here we will find bounded plane and select the curve so that we can create a surface. Let's move to manufacturing, and manufacturing, first of all I am going to define my workpiece. Click, and the part is this surface, because for a curve you cannot select any curve as a geometry, so we need a solid or surface. Although I am trying to select this, but it is not selecting my surface. So click here and change this to face and select, and surface will select. So if you want to create program for 2D, so you cannot see the 3D verification. If you want to see the 3D verification, you need surface or a solid as a part geometry, and click OK. Now for blank, I am going to use bounding block. The boundary is selected, still the height is not defined, so I am using 4.0 as a depth, right? Display this blank, OK, and OK. Here the surface is still visible, so hide this bounded plane surface. Now we need a tool, so I have this tool. This is a smaller tool. Now I want to remove the material which is inside this curve or outside. So it depends upon you where you want to machine. So I'm going to use this planar mill. Select the program folder, tool, workpiece, and method. Here specify the boundary. For boundary we can select the curve, so select this curve and click this by connected curve, so whole curve is select in single time, and the tool side is outside, so it will remove outside material, but I want to remove inside material, so keep this inside. Add, this is the second one. Tool is inside, add, select, tool is inside, add, and click here. Tool is inside, add, and for this circle the tool will remove material outside the circle, so keep this outside, add, and again do this for this circle, and OK. All the curves are now selected. Now we need to define the floor. So floor is 2 mm below, right? So this is the depth, or if you want you can enter 1, OK, and you can see the tool path is here, and the depth of cut I want 0.3 as a depth of cut, so number of passes or depth of cut will come. I want to check it, so click here. We have follow part or follow periphery, depend upon you which type you want, and generate, and 3D verification, 3D dynamic, and play and say this. This is working with level based. If you want to use depth base, change to depth base. Here the diameter of the tool is still big, so this material is not possible for this tool to remove, and this few shape also. So hope you understand this, how to create the tool path for 2D curves. Thank you for watching. Have a nice day.